Here we'll show the StrongWeigh wireless sensor installation on a typical front steer axle. This is a 12K axle, but the installation will be the same for any I-beam front axle. And notice that this axle is clean of dirt and grease. On a real truck that won't be the case, so make sure you first clean the top center section of your axle's beam thoroughly. StrongWeigh sensors are incredibly sensitive for maximum accuracy, and any dirt or debris between the axle and the sensor could skew its readings. I'm Josh, an engineer here at StrongWeigh, and I'll walk you through the install. Before we start, the sensor we're installing is the wireless deflection sensor, which has mounting brackets on top, battery compartments on either end, and hardened steel teeth on the bottom, which will bite down on the axle to help hold it firmly in place. There will also be a stiffener plate like this bolted to the top of the sensor. Don't remove it until after installation is complete. Along with the sensor itself, the other items included in the kit are 2 batteries, 2 battery caps, 4 washers, 4 bolts, 2 hooks, 2 chains, a template for marking center on the axle, and new orders will also include a torque wrench and socket at no additional cost. And other tools you'll need are just a hammer, a pair of channel lock pliers, a 1/2-inch wrench, and a permanent marker or paint pen. Okay, so step number 1, install the batteries in the sensor. First, connect the wires on the end of the battery to the wires sticking out of the sensor. Then push the wires down into the battery compartment and insert the battery. Then screw on a battery cap and hand tighten. Then same thing with the other battery on the other end of the sensor. The little wire connectors can be connected only one way, so just don't try to force it or else you might bend the pins. When the connectors are both facing the right direction, they should connect easily. Now tighten the battery caps with the pliers. These caps are plastic, so you don't want to over tighten them. Just tight enough to compress the O-ring for a waterproof seal. Next, we'll connect the chains on one side of the sensor. Take a bolt, stick a washer on it, and run it through one of the slots on the sensor from the top and thread it onto one of the chain ends. Only a couple of turns, just enough so the chain doesn't fall off. Repeat for the other chain through the other slot on this side of the sensor. Again, only a couple of turns so the chain is connected but hangs loosely. Now flip the sensor over, and on the other side we'll hang the chain hooks. Similar process, bolt and washer through a slot on the sensor from the top and thread the hook onto the bolt. And here again, only a couple of turns just so the hook doesn't fall off. Next, we'll take our template and mark centers on the axle for sensor placement. It isn't crucial that the sensor is mounted precisely in the center, so you can usually eyeball it close enough. An I-beam axle typically has a ridge on top at the center of its width, and a protrusion like this on the front and back at the center of its length. You can use these as references while keeping the template's edge parallel with the axle's edge. Or you can always use a measuring tape to center the template if needed. Then, using your permanent marker or paint pen, place center marks using the notches in the template. Now we place the sensor on the axle. It can face either direction with the chains hanging in the front or the rear. And we can align and center it using the marks we just placed on the axle. Next, we pull the chains under the axle and hook them onto the chain hooks, hooking the chain as tight as possible without it being difficult. With the hooks facing outward, away from the axle, pull the chain tight to the hook, and whatever chain link touches the hook, the next link further away should easily pop into place on the hook. Again, so that it isn't difficult, but the chain beneath the axle isn't more loose than necessary. The chains are long enough to accommodate various axle sizes, and any excess chain links can just hang freely from the hook. Now, with both chains hooked, they should look about the same minimal slack hanging under the axle and the same number of excess chain links hanging from the hooks. Now tighten the bolts incrementally, each bolt a little at a time, so that they're tightened fairly evenly. That way you don't accidentally run out of threads on one bolt. The sensor may get jostled around some, so as you go, double check that the sensor is still properly centered and adjust it as needed. I'm doing the initial tightening of these bolts by hand and with the torque wrench, but you can use an electric or air ratchet to get them snug quicker. Just be careful not to over tighten them with the power tool. The final tightening should always be done with the torque wrench. When the chains get tight and you start to feel the bolts needing more force to tighten, make sure you then start tightening the bolts using slower, smooth motions with the torque wrench. With this particular type of torque wrench, you can feel a little click when the torque limit is reached, but you might not feel it if you're tightening too quickly or aggressively, and you could then over tighten. So nice and smooth, I'm tightening each one until that little click is felt. 30 foot-pounds is the torque setting here, but check the install instructions in your kit or on our website in case it's different for your install. Now, once all the bolts are torqued down properly, take your hammer and give each of the sensor mounts a solid tap on top in each corner. This makes the sensor's teeth bite in a little further, which loosens the chains a bit. So then, tighten the bolts once again with the torque wrench until the torque limit is reached. Then repeat, hammer again and tighten again, and keep repeating until the bolts don't tighten any further after hammering. This indicates that the sensor's teeth are fully sunk in. Here we needed only one round of hammering and retightening. After hammering the second time, all 4 bolts are still tightened to the torque limit, which means we're finished tightening the sensor down. Finally, after the sensor is completely mounted, we remove the stiffener plate from the sensor using a 1/2-inch wrench. This stiffener plate keeps the sensor properly aligned through shipping and installation, but you don't want to leave it on because the sensor would lose all its sensitivity and accuracy. So we remove it, and there you go. The StrongWeigh wireless deflection sensor is installed on the front steer axle. No wires to run, no welding, and no waiting for glue to cure. Pretty easy.